Good afternoon, distinguished colleagues and guests. It's 24th of May, 2021, 2 p.m. Moscow time. We're beginning the panel session for the defense of the thesis by Mikhail Voloshin. The thesis is submitted for the academic degree of the candidate of sciences in physics and mathematics. The specialization is 051301, System Analysis, Management and Information Processing, Physics and Mathematics. The topic of the thesis is the analysis of the asymptotic behavior of solutions and the synthesis of stabilizing controls for nonlinear, non-stationary difference systems. Under the order issued by St. Petersburg State University as of September 17, 2021, number 1163/1, I, Alexander Degtyaryov, Doctor of Sciences in Physics and Mathematics, Professor of Computer Modeling and Multiprocessing Systems Department of St. Petersburg State University, was appointed the chair of this dissertation board. And let me introduce the members of the board who were in order as well. So here we have Alexander Kamachkin, Doctor of Sciences in Physics and Mathematics, Professor of the Higher Mathematics Department of St. Petersburg State University. And also Vyacheslav Provorotov, Doctor of Sciences in Physics and Mathematics, Associate Professor. Provotorov. Yes, I beg your pardon. Professor Voronezh State University. The following members of the board are working remotely. Valentin Hai, Doctor of Sciences in Physics and Mathematics, Professor, leading researcher of the RAS Trapeznikov Institute of Control Sciences. Do you hear us and see us? Yes? Yes, I do. And Denis Yefimov, Doctor of Technical Sciences, National Institute for Research in Digital Science and Technology, from France. Do you see us and hear us? Yes, hello. We also have our candidate for the degree, Mikhail Voloshin. And we also have the thesis supervisor, Professor Alexander Alexandrov, Doctor of Sciences in Physics and Mathematics, St. Petersburg State University Professor. Dear colleagues, I would like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University, and it is also interpreted from Russian into English and vice versa. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Mr. Voloshin online. The questions regarding the thesis or scientific discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. The questions must be related to the presentation of the candidate for the degree and to the content of the thesis, and do not forget to give your name and position if you submit a question. The questions that have nothing to do with the scientific discussion or the dissertation text will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local normative acts, the session of the dissertation board is valid, providing 2/3 of the appointed board members are present. The total number is not to be fewer than 4 people. The dissertation board consists of 5 people. 5 are here today, including 2 members of the board remotely. We have a multimedia connection with all the members of the board, as well as with our candidate for the degree. Therefore, we have a quorum. Our session should not last more than 3 hours. Should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Chairman's replies to questions, if any, 5 minutes for that. Then the candidate's presentation providing an overview and the findings of the research. 15 minutes for that. Next come questions to the candidate regarding the presentation, no more than 2 minutes per question. Fourth, the candidate's replies to questions, 10 minutes for all the questions. Then 5, reports on the thesis. The board members will be taking the floor in turns to provide their reviews on the thesis, and they can also ask questions on the text of the thesis. 10 minutes per speaker. Then the chairman's report on the thesis, also 10 minutes for that. Then come candidates' comments about the reports on the thesis and replies to questions, if any, 20 minutes for all questions. Then open discussion. Anyone present at the defense may state their position or ask questions on the thesis. 2 minutes per speaker. And if you want to ask a question, kindly fill in the registration form and introduce yourself before I give you the floor. Then the chairman will ask the questions submitted during the broadcast via our website. 10. The candidate's replies to the questions, 2 minutes per question. Then the presentation of the candidate's thesis supervisor, 3 minutes for that. And then we're going to have a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense is not broadcast. 5 minutes for that. Then comes open balloting, vote counting, and recording of the results in the protocol. Then we're going to make a decision on whether to confer the academic degree or not. And finally, we'll listen to the candidate's closing speech, 2 minutes for that. So, distinguished colleagues, any comments or questions on our agenda? Okay, no questions. Dear colleagues who are working remotely, any questions? No questions? Okay. If there are no objections or no questions, let us proceed. But before we do that, I kindly ask you to switch off the sound on your mobile phones. Thank you. Because it may interrupt us. Okay, let me start. First comes the chairman's presentation. So the thesis by Mikhail Voloshin for the academic degree of Candidate of Sciences in Physics and Mathematics, Specialization 05-1301, System Analysis, Management and Information Processing, Physics and Mathematics, is titled The Analysis of Asymptotic Behavior of Solutions and the Synthesis of Stabilizing Controls for Nonlinear, Non-Stationary Difference Systems. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued February 2nd, 2021, number 788/1. Mr. Voloshin has prepared his thesis at St. Petersburg State University, and Professor Alexander Alexandrov, Doctor of Sciences in Physics and Mathematics, St. Petersburg State University professor is the thesis supervisor. 17 published works describe the research findings, and those include 2 papers published in peer-reviewed journals recommended by the Ministry of Education and Science, and 4 papers in publications indexed in Web of Science and Scopus. The candidate has submitted the full set of documents to the academic secretary. The above-mentioned documents comply with Item 12 of Section 3 of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University, and all the documents, as far as I'm informed, meet all the necessary requirements and are found in the certification file. And the Curator of the Defense, Madam Natalia Karpova, member of the Department of the Dissertation Board Support, has all the copies. And before I give the floor to our candidate for the degree, I would like to ask the following question. Distinguished members of the board, do you have any general questions to the candidate for the degree, and is there need to consider the whole set of documents submitted? No? No? Okay, thank you. Thank you, colleagues. If there are no questions, let's shift to Article 2, the presentation by Mikhail Voloshin. So, please, Mikhail. Hello, my name is Mikhail Voloshin. The topic of my thesis is the analysis of the asymptotic behavior of solutions and the synthesis of stabilizing controls for nonlinear non-stationary difference systems. The thesis has an introduction, 5 chapters, conclusion, and the list of literature sources. In Chapter 1, we have the major definitions, notions, and results that are used in the work. In Chapter 2, I give the sufficient conditions for the uniform asymptotic stability of solutions and for uniform boundedness of non-stationary difference system of equations. And on the slide you see the definition of such generalized homogeneous right-hand system. So all the components of the right side should meet this equilibrium, so they should be generalized homogeneous function of the same class, M1 and M and their order depends on the number of component, and it equals mg plus alpha. And let's make a proposition 2.1 on the uniform convergence of arithmetic mean for the right sides of the system on this S. Then for system 1, we can consider the averaged generalized homogeneous system 2 with fx, right side. Then let's presume that zero solution of the average system 2 is asymptotically stable. In this case, we find a positive generalized homogeneous function of Lyapunov, Vx, with a wave. It will be continuously differentiated. And this is supported by work 57. And in order to conduct the necessary transitions, we should have presumed uniform boundedness and or uniform continuity on this S. The stability of non-stationary systems of differential equations conditions were studied in the works that I've given on the slide. In work 26, they offer a way to construct non-stationary function of Lyapunov for homogeneous differential systems, and I use it in work 69. And this construction is given on the slide, the discrete analog for the Lyapunov function. Then I've considered the increase of this function and got assessments for the function, for the increment of the function. And these assessments allowed to prove proposition 2.2, which is brought for the defense. It says that when we perform these propositions, if alpha is more than 0, the zero solution of the first system is uniformly asymptotically stable, but if alpha is lower than 0, then it's uniformly bounded. And compared to different systems results, we have the conditions that provide for the uniform character of the asymptotic stability of solutions, and there is no uninterrupted differentiation of the right sides of the considered systems. In Chapter 3, we have discrete analogs for ordinary differential equation systems. And I take the condition of existence of controls that provide for the uniform dissipative character of systems of difference equations that describe the chain of continuous connected integrators. And I bring it this idea for the defense. And we also have the conditions of stable equations for the differential approximation of a vector equilibrium of Ray. And here you see the linear management, number 4. Such a choice of control allows to stabilize systems in which we can measure just this Y component. And such systems for ordinary differential equations were considered in work 64. On this slide, you see the wording of 3.4 theorem that is also brought for the defense. And we also see that based on proposition 2, we use the averaging method because we need to have this convergence of matrices. The choice of matrices is carried out based on 3 and 4 conditions. We need an asymptotic stability of the zero solution of subsystems of a lower size, some auxiliary systems 3 and 4. Thus, when we perform these 4 conditions, this linear control 4 is stabilizing for the third system. Chapter 4, we give the conditions for asymptotic stability and for dissipative bounded character of fifth system with right sides as combinations of phase variables. And the stability of such systems was studied in work number 65, and we presume in our work that the continuity of matrices is bounded, and as in chapter 2, this uniform convergence is found in these matrices. In this case, we have an averaged system of difference equations, and in works 667, such equations were considered, and we offered modes to construct the Lyapunov functions for such systems, and we use one of these modes and make a proposition 4.3. So this matrix will be negatively defined, and using the matrix of lambda coefficient, we can construct the Lyapunov function for the average system. Based on this function, using the method of chapter 2, we construct the function of Lyapunov for the system. We get values for it, and these values allow us to prove the theorem 4.1. It says that when we perform certain propositions, if all values are higher than 1, then zero solution for the system is asymptotically stable, and if they are lower than 1, this system is uniformly bounded. In chapter 5, I give sufficient conditions for the uniform asymptotic stability overall if we solve 3 classes of nonlinear different systems with switches. These results are brought for the defense. And on the slide, you see the general view of this system with sample interval h, and we use the sigma function that changes a p matrix in the right side of the system. And let us define all the switches between the subsystem theta and the interval lengths between the switches as ti. Then we introduce boundaries for these values and use them to obtain the final results. And let's make the proposition for all the systems. For example, we have lambda coefficients for which the matrix will be negatively defined. In this case, we can construct the Lyapunov function for each subsystem in any permissible Fi system in the right side. And let's presume that these functions for f meet the Lipschitz requirement for on the real axis. And in this case, we'll have this constant c, and any function of Lyapunov here is bounded by any other, using this inequality that we have in the presentation. And for theorem 1, we make a proposition 5.3, and in any particular case, it will be fulfilled if the function of the right side are monotonously growing and meet the linear estimates. The thesis gives a general proposition 5.3, and the example to this theorem has not just the monotonous function in the right side. And in this case, we formulate the result that if the sum in theorem 5.1 is uniformly going to infinity, as opposed to m, then in any sample interval h, any solution of the system with switches will be asymptotically stable overall. And if we replace this proposition by proposition 5.4, it will be performed if f are monotonously growing and meet the order results. In this case, we can get a result that is formulated in 5.2 theorem. If the sum goes to infinity, then in any sample rate of h, the zero solution for the switch system will be asymptotically stable on the whole. And we should mention that in this theorem we have stricter limitations for the switch law compared to the previous theorem, but at that we have weakened restrictions on the right sides of the system. And as for 5.5 proposition, let's make it, and it will be true if we add up a condition of saturation in high values of state variables. The f functions in the right sides are saturated and they have permanent values. In this case, we can prove the 5.3 theorem if these convergences are found here. Then in any sample interval, the solution will be asymptotically stable overall. And we see that compared to the previous theorem, we required even more strengthening for the switch law. And that's it. Thank you. Thank you. Now we shift to questions. First of all, the general questions from the members of the board, if there are any. After that, everyone present who wants to ask a question may do that. And are there any questions submitted via email? No, not yet. Okay. Do the members of the board have any questions on the report and the content of the thesis? So, please. Any questions from our colleagues who are working remotely? None. Okay. But we should have some. Therefore, I'll try to start a discussion and ask a question. So, could you please tell us, Mikhail, you have quite a theoretical work and you've made a presentation. Could you please tell us, do you have any ideas that you can share on a certain real technical system in which you can apply your developments, for example, in a vessel control system, for example? From the point of view of practical application for your system, what can be chosen here? What can help to organize some real practical system? Well, unfortunately, in my work, the practical value goals were not considered. I can just say something general, that if in this problem we'll see a disturbance system that meet the requirements that I have in my work, then we can create stabilizing control. Or if in this area we'll find certain class of problems, we can use the thesis methods in order to obtain the construction of controls methods. Thank you. Okay, the second question is the following one. Could you please tell me, you said that if you have any, disturbance, what kind of disturbance are you talking about? Should it be regular or irregular? Should it be a certain noise? And if so, then what kind of noise? What kind of characteristic? Well, in this work, in chapter 2, I considered disturbances. The main thing here is that we have the average, and basically the work is based on order functions, so this kind of disturbances. Basically, this approach of construction of the Lyapunov function can be used for other fields as well, for other similar disturbances of the right half side. Okay, thank you. Any other questions? Okay. Thank you. Alexander mentioned a key word, this development. So I ask a question about the development. The results that you presented, well, are quite impressive, and I like them a lot. Therefore, initially I did not even want to ask a question, but now I want to voice it. What would happen if, in the development of your results, you would consider differential equations in particular variables? Or, as in contemporary analysis, they say the equations in band fields where you use this function when you have the reflection of the variable for differential equation as a function for an ordinary differential equation, and yet another variable, or maybe some other variables, can be used that can give an opportunity to, well, I said reflection, but you can talk about the function of two or several variables. And by the way, you see my experience, and Alexei Zhebko is here as well. Our experience shows that many results that can be found for ordinary differential equations, they can be used for system with distributed parameters. The question is as follows. Have you thought about the topic? That's my question. Well, unfortunately, I was not dealing with this issue. Maybe luckily, that's a very long work, otherwise you won't achieve the goal. Okay, so you haven't thought about it? Yes, I wanted, to approach the problem that I understand fully. That's why I didn't consider this problem. Okay, any other comments, Alexei? Yes, the thing is that you consider hybrid systems in Chapter 5. And that's a question. Well, why do you choose such a class of hybrid systems? Because you see there are numerous hybrid systems, and you've chosen just these ones. So how can you explain that? Some applied goals that you try to achieve, or maybe you decided to improve the results of the colleagues that considered this topic before, but well, partially everything. On the one hand, these systems are similar. You use this formula in the right part, and I add up the sample interval that I haven't seen before, and certainly there is practical application for the systems. Well, I can't say that I developed it in detail, but such systems are widely applied when we construct the automatic control systems and neural networks for some biological purposes. So that's it. Okay. Okay, thank you. Thank you. Other questions from our colleagues who are working remotely? Yes, a technical question. I have a question on your 551 theorems. You form a condition for the stability, yes, for example, this one, for the stability of the commutation systems as a sum of time of commutation that goes to infinity. But basically for systems with switches, we use such standard approaches as real-time limitation or dwell-time limitation, and you don't use this wordings. Could you please explain what's the difference and what's the connection here, and why don't you use this wording of conditions for theorems 5 and 5.1? Well, 5.1 theorem I mentioned that these systems are using strict limitations on the right side, and they are approximated to the linear systems, and for them we do really have a condition that says that the time intervals should be equal or higher than a certain value, and in my work I formulated this even stricter limitation. But on the other hand, you see in the thesis I have this 5.2 theorem, and here it turns out that you have to introduce even a stricter limitation for the transition switch law, and this allows to weaken the limitation on the right side. And this theorem, 5.2 and 5.3, they add up the stricter limitations, and in them we see the limitations that were done in theorem 5.1. So it turns out that in theorem 5.1, if we use this general approach, we can even weaken these limitations more. I believe that's possible. But right now, the results of these most recent theorems resemble the well-known results for differential equations. And, well, thank you very much for the comment. I believe I should try to use it in theorem 5.1. I believe, yes, your proposition 5.3 means that your system is always quicker than the linear one, because for linear we have this dwell time condition. I don't know, how do you say it? This dwelling time. Maybe you can rewrite this condition for the attenuation time. I have yet another question. When you introduce your system class, and when you specify that for homogeneous systems you also always have this Lyapunov function, you make a link to the Rosya work. I believe the first one to obtain this result was Professor Zubov. Why don't you mention him? Yes, over here. Why don't you refer to Professor Zubov's results? Why can't you use them here? Well, that's it. I believe I mentioned these results together with Rosya in my thesis, but they don't allow us to get the function that is differentiated for certain periods of times. And Rosya's system is a bit better, it's more advanced, and you can get this function numerous times. I like this work, therefore I decided to use it. Okay. And maybe one last question. When you consider your system with averaging, you can give ordinary homogeneous system as a sum with an error, and you have it on one of the slides over here. Maybe in this case you can just take this averaged part, it converges to zero. You can consider it as a kind of disturbance, and you can use the discrete results for such systems. Well, I believe this approach can be used. You can use it this way, but in my work I decided to use the concept of transition from these homogeneous systems from chapter 2 to such systems, and you see that the right part component is given as a sum of averaged part, and the other part that has a zero mean. And if we use these results, I believe we get what you mentioned. We can give it a try. Okay, thank you. Okay. Valentin, any questions from your side? One general question. Do you see the continuation of your works, or maybe some theoretical application or development, or some practical application? Well, overall, this work has a possibility to go in two fields. I did not decide which way to go, how to continue this work. I can't give you some insight. But if you continue working in this field, I believe you can get more interesting results. Okay, thank you. Any other questions? None? Okay. Any questions from those who are not the members of the board? None. Okay. Did we get any questions submitted? None. Okay. So let's switch to the next step. Now we're going to listen to the reviews from our members of the board. And if you will read out external reviews if any of them are submitted. And I believe we should use the standard option to answer the questions at once after each speech, not in the end of all the reviews. Okay. No external reviews, as I'm informed. None. Okay. Therefore, let's listen to our members of the board, and as all the reviews were already published on the St. Petersburg State University website, I offer not to read out all these reviews, but rather dwell upon the basic points, questions and comments to our candidate for the degree. So, do you agree with that? Okay. Well then, let's start reading the reviews. So let's go step by step. First comes Alexander Kamachkin. Please, you have the floor. Well, first of all, I'm going to give the general characteristic, what was done in the thesis. Broadly, this thesis is dedicated to a qualitative study of the dynamics of nonlinear, non-stationary difference systems due to the new technological order with a broad introduction of digital element base into the computation devices. The relevance of the study is not questioned, and basically, the thesis is dedicated to the study of nonlinear, non-stationary difference systems on nonlinear approximation that is described in a discrete system with a homogeneous right-hand side. Then I considered the results in my review that were already mentioned. Therefore, I'm going to shift to this statement part. So the candidate for the degree is familiar with all the contemporary set of Lyapunov function construction for all systems, and all the theorems have the detailed examples, images in a variable space. And the issues considered in the thesis are dealing with very delicate issues of the theory of different systems, and the candidate for the degree managed to acquire new results and improve the old ones. Therefore, I want to add that there was a question on the application. I believe these examples show that if needed, anyone who uses these methods could apply these solutions in some practical application. Then, as for the literature list, it gives us the current state of the topic. All the results that are given in the thesis are published, including 6 works in publications recommended by the Higher Attestation Commission. And we also have mathematical models used in theory of automated regulation and in neuron networks. And overall, the thesis is a finished scientific work. All the results are mathematically proven, and I found no mistakes in this proof. As for the remarks, in wording of lemma 2.3, you should remember that we have this inequality. R1 is more than 0, and R2 is more or equal than R2 R1, and you should give the connection of these values here. Then, in the wording of theorem 5, you should characterize H0 value. And fourth point, that's a general point. You've chosen this option when you first give all the auxiliary facts and propositions, and then you give proofs with links. And Certainly this reduces the text volume, but it makes the understanding of material more complicated. However, these remarks do not compromise the high value of the results. This is by Mikhail Voloshin, titled "The Analysis of the Asymptotic Behavior of Solutions and the Synthesis of Stabilizing Controls for Nonlinear and Nonstationary Difference Systems," meets the requirements of the order as order on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Voloshin deserves the academic degree of the candidate of sciences in physics and mathematics in specialization, system analysis, management, and information processing, physics and mathematics, and Article 11 of the above-mentioned order is not violated. That's it. That's it, what I wanted to say. So, please, Mikhail, you can answer. Thank you very much. As for the wording of this 2.3 lemma, well, this lemma is true and it is applied in more general limitations. R2 should not be higher than R1 due to the transitions that we see. And this is used in the work further on, so the limitations that were introduced, they should be as they are given. And as for 2.7 lemma, the radius R0 does not depend on other values, and you see all these limitations introduced. R0 should be higher than 0, and R2 can be equal or higher than R1. So R0 is not connected to R1 and R2. And as for H0, this value is given before the theorem, as in the right side of the system. In the end of paragraph 5.1, we give it that we'll take a smaller sample interval. And as for this, as for the general comment, certainly it reduces the amount of this. It reduces the size of the text, but I did not think that it can be quite inconvenient to read. Yes, I'm satisfied with the answers. Thank you. Okay. Next comes Professor Provatorov. So, dear friends, also omit this part of my review that's dealing with relevance and with such issues. I believe the candidate for the degree mentioned it quite well, and we see it by the results of the work. And I'm going to dwell upon the aspects that impressed me most. And I, person dealing with similar issues, what impressed me most? And this particular derivatives. In the title you have it, the detection of sufficient conditions for uniform asymptotic stability for difference equations. These are quite in-depth results in that you have in chapter 2. And these are the results that you can use in other chapters, the results of chapter 3 and 4 and so on. And I'm going to tell you what made me ask the question. For example, you give, well, ways to use similar goals for in particular derivative equations, and you have it in this last line. This function x is for one variable t. And let's imagine that that is a reflection that depends on yet another variable, or maybe on a vector variable, to here have this differential equation. But it's written in the terms of band space equations, because the solution here is a reflection. And let's imagine that for this equation we are going to carry out something that Rota mentioned, semi-discretion method. And on variable t we can use it, and you get this differential difference equation, and therefore we'll have an opportunity to use the results that you present. So that is what I thought about when I asked my question, because I saw some ways that we used in our studies. You see, in the theory that was studied well for ordinary differential equations and for ordinary systems, it can be also used in this situation for differential systems with distributed parameters, for particular derivatives. And that's for the first thing that I wanted to mention. And the results are quite reliable, and it's quite this work is quite convenient to read. And that's it for the research part. But, you know, I've never seen dissertations without any faults. Therefore, I've seen them here as well, but mostly these are the comments that can be characterized as not as comments, but as wishes for your future work. These are these technical remarks. Alexander, should I read them? Yeah? Yeah? Yes. Okay. I should make them public. Okay. The review of the current development of the program would only be more advantageous if it would contain the most recent works of Astolfi, Richard, Polyakov, Yefimov, and so on. I believe so. Maybe you could have given a wider list of works considered, but the same is true for the stability consideration method. Because that's a field that is quite actively developing. Then Chapter 3 is dedicated to issues of the discrete nonlinear systems control. And I make a remark here. In differential equations, you know, nonlinear systems are should be quite delicately treated, and your works would be quite useful here. Then Chapter 3 is dedicated to control goals for discrete nonlinear systems, and you use the analysis of Chapter 2 to analyze. And I believe you should have explained the approaches that you to the use of the results that you've acquired in Chapters 4 and 5. Then you gave a range of theorems on stability and marginal limitation of the systems, and it would be expedient to get the estimates of the transition process's time. And on pages 64 and 65, you write that initial input data of solutions were approximately evenly chosen on the sphere. You should explain this term, or maybe specify it somehow. This approximately uniform. But still, these comments do not compromise this high mark of the work, and the conclusion is as follows. A thesis by Mikhail Voloshin titled The Analysis of the Asymptotic Behavior of Solutions and the Synthesis of Stabilizing Controls for Nonlinear Non-Stationary Different Systems meets all the basic requirements of the order, and Mr. Voloshin deserves the academic degree of the candidate of sciences in physics and mathematics, in specialization, system analysis, management, and information processing, physics and mathematics, and Article 11 of the above-mentioned order is not violated. And so, that's it. Okay, thank you. Mikhail, you can answer the questions. Thank you so much for the comments. As for the use of results of Chapter 4, the approaches are similar to the ones in Chapter 2, and we have Chapter 3 where we use this theory of Chapter 2, and in Chapter 4 we can have something similar for similar systems, and in Chapter 5 I omitted these ways of use. And the most obvious one is to change this law of switch of systems and to master this switch time, to manage this switch time. And as for the uniformity of choosing the points, I should have demonstrated asymptotic stability and boundedness of the systems in 4 dimensions of initial data. And if you choose the points for some randomly, it will look like there are huge spaces between the points, and I used a way to define this space between the spots, and therefore they cover the sphere quite uniformly, and I should have specified it, certainly, but that's a kind of demonstration of stability. So you've kind of introduced your own topology of choice of these points, yes. But the goal was to scatter them rather evenly, not to have some empty spaces. Okay, are you satisfied with the answers? Yes. Now let's switch to the reviews of the members of the board who are working remotely. And now I would like to give the floor to Professor Yefimov. So please, Professor, you have the floor. Okay, thank you. I'll try not to repeat the comments that were already mentioned by colleagues about the relevance of the study. And I've already asked some of these questions that I had in my review. Certainly the topic is quite relevant. It is dedicated to a very complicated problem where we have both linear systems, dependence on time, and discrete character. And certainly this problem is quite in demand in practice and in theory. And I really liked the work, the thesis. It's clearly written, everything is clearly defined, and we don't have certain misprints. Therefore, I just enjoyed reading the text. As for the results, they are published in numerous journals, and their technical level and correctness are not questioned at all. And I've already asked some of those questions, and some of them are technical, as for misprints, as for wordings of these theorems 1.1, 1.2, and some results like lemma 2, they were received in other works as well. And I've told a function that you should reduce the control that you later on use. But basically, I would ask this question, as Professor Provatorov mentioned, about the positioning of your results compared to other works that were previously published on the issue. For example, the studying of homogeneous systems, the development of the homogeneity theory method for the certain class of systems. Basically, these topics are quite popular and there are a lot of novel results, and in your literature review you don't refer to them, and I'm ready to see that regardless of that, your results, all your results are original and novel, but your thesis would be even more even better if you could compare your results with the data that other colleagues received. Basically, these are the questions that I wanted to mention, but regardless of them, as I've already mentioned in my review, I believe that Mikhail should be awarded this academic degree of the candidate of sciences, because I really liked reading your work. Thank you so much. So, your opinion is quite positive. You decided not to read out this formal part, but to phrase it in a different manner. Do I get it right? Yes. Yeah, that's a free translation of this part from my review. Okay. Mikhail, you can answer the questions. Thank you so much for the comments. As for the misprint in this theorem 1.1, 1.2, I did not see them in my version. Maybe that's the program failure, because I didn't see this typo. As for this work, 64, I just make a link to these results, but I don't exclude that similar results could be obtained in a different work. I just use the work that I've seen. And I agree that my work would be just better if I made an overview of the current state of the problem, if I would add up. Certainly, thank you so much for the comment. And as for lemma 2.1, there's this series of lemmas. You know, I did them quite long ago, and they are quite simple. Certainly, they can be proven by other works, by other groups, and I don't use them quite often, and I don't take them for the defense. So thank you. Okay, are you satisfied with the answers? Yes. Now I give the floor to Valentin Tai. Well, I liked the work. It has logic. And as for the last chapter, it's a bit, it stands out a bit, and it's also very fascinating. I won't repeat all the words that colleagues mentioned already, but I want to give my opinion that there are such benefits in this work. For example, Mikhail proved the theorems and provided examples for the solutions. Second point is that the theorems are not formulated like if, then so. We can always check what we get in theorems. And the next point. The candidate for the degree did not search for certain characteristics, continuous characteristics. He drew the conclusions himself, and it means that he is a very good researcher himself. And certainly I would like to mention that the thesis is written quite well. I like the Russian language a lot, and the Russian mathematical language as well. And as for the results that were already mentioned, and I give my review that was already published. And I would like to draw your attention to the following points, to certain remarks. Certainly, I would like you to reflect this word, a combination, Lipmanov method, in the title. And I've thought about different options, and certainly I concluded that it was very hard to do. However, the Lipmanov method, you always refer to it in your study. Second point. In chapter 3, after the study of nonlinearity of the homogeneous functions, you mention a system that allows this distribution. And certainly it would be interesting to give these systems, first of all, the ones that you've studied, because you start with the systems that are already clear. And there are such problems that you do not give the relay equation. You describe it, but you don't give the situation in which you can see it as an averaged value. And certainly this thesis is quite theoretical, and the application of it is demonstrated by certain examples. And for example, chapter 3 can also be considered as an application chapter, but not to technical systems, but rather the application that it will lead us to a different level of our abstract idea. What I like most is the last chapter, and I believe it stands out a bit, all the switch systems. They managed to get global stability, and certainly that's a very good result. And overall, all the results are interesting. All the comments that I've mentioned, for example, the remark on very, complicated wordings. These are some editorial comments. But what I like most is that this thesis is quite logical. And all the analyzed problems, they are interdependent. And I liked the work, and I've already given you all my comments on it. Okay, thank you. And your conclusion is positive as far as I understand? You just did not read it. Just admitted it. Okay, thank you. Mikhail, please, you can answer the questions. Thank you very much for the review. As for Rayleigh equation, indeed, I do not study the practical application. I just make a link to the fact that it's used in mechanical systems with potential dissipation forces. Thank you so much for the typo. Indeed, I had it. Alpha should be smaller than 0. But certainly this can be drawn out from the later warnings. And I agree with other comments as well. Thank you. Thank you. Are you satisfied with the answer? Yes, I am. Okay. And now it's my turn to give my review. Well, to some extent, it's a bit easier for me to give my review because many things were already mentioned. Therefore, I won't dwell upon the relevance, novelty, and other topics that were already mentioned. What I want to mention is that indeed the work is really a theoretical one. And for me, and I'm a practitioner, I'm Doctor of Technical Sciences, and I'm most interested in application of some ideas. You see, I always remember the phrase of an outstanding scientist that there's no thing more practical than a good theory. And as I see here, this good theory is found in this thesis, and other colleagues have already mentioned that as well. Therefore, I would like to concentrate on certain, well, simple remarks that I've formulated in my review, the ones that are connected. Well, some of them were already voiced after your presentation, but still I need to read them out in my review. Well, first, the remark that I'm giving is that in the thesis, your examples, the examples that you gave are quite illustrative, and it would be interesting to consider a practical problem. I've already asked this question, I've already got answers, and I agree with them, and I understand what is the field that the author can apply this results, in which the author can apply this result. The second question is quite technical compared to the results that we already know. The novelty of theorems is in the expansion of the class of permissible non-stationary disturbances in which we still see stability and boundedness. However, you consider one non-stationary function that is introduced in paragraph 2.6, and unfortunately you don't study the issue of description of function classes for which these results are not applicable, and your theorems allow to prove the preservation of the conditions. And in Chapter 3, you consider some goals of control of nonlinear and non-stationary difference systems, and you use well-known modes of construction of equations for uninterrupted systems. Therefore, the novelty of this chapter is not in the new control methods, but in the study of the influence of discretization and non-stationary disturbances on closed-loop systems. And there are certain technical remarks. For example, unfortunately, the author does not give specific results of applied problems that would use the models that are described with nonlinear systems. And from my point of view, the number of provisions brought for the defense is a bit excessive. For example, the thesis you formulated 7 provisions, and to some extent they are a bit interdependent, and I believe you should have united some of them, make them more informative, and in this case they would be, I believe, better, because I'm used to having 3 or 4, provisions brought for the defense, and 7. Yes, it's something for the thesis of a Doctor of Sciences. And in conclusion, I should give this phrase: the thesis by Mikhail Voloshin meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Voloshin deserves the academic degree of the candidate of Sciences in Physics and Mathematics in Specialization 051301, and Article 11 of the above-mentioned order is not violated. So that's it. Thank you. If you're ready, you can answer the questions and comments. Thank you so much. I agree with your remarks, with your review. I tried to give examples from literature for nearly all the systems considered, how it's used in practice and in theory, but unfortunately I did not do a detailed review. And as for the provisions for the defense, they were divided because certainly I could unite them, but they were referring to a certain volume of work. Okay, next question. Distinguished colleagues, distinguished members of the board, is everyone satisfied with the answers? Not for all, satisfied with all the answers for all the questions? Yes? Yes? Okay, now let's listen to our guests of the defense. Those who are not members of the board, please, you have the floor. So introduce yourself, please. Professor of the Faculty of Applied Mathematics and Control Processes, Alexei Zhabko. It seems to me that different systems that are considered, they could be conditionally called, well, the mark processes that are described, and the semi-mark processes of transition. And those propositions that were made regarding this integral characteristics of switch moments, they reflect this population goals. And there are these switch moments that can be regular, but as seasons, we can have different switch periods. These are regular parts. And there are some random switch moments that are associated not with time intervals, for example, time of the year, but with sociological things that emerge regardless of time, wars, for example, and that all influences the transition of function. And I would like to emphasize that these moments really meet the propositions of all these sums. Therefore, I would say that that's a good application that can be quite varied here. That's it. Okay, thank you. Anyone else? No. Okay. Do we have any questions submitted online on the text of the thesis? No. Okay. So that was the last call. And if any questions are submitted, we will no longer consider them according to our procedure. So, next part of our agenda is as follows. Now I would like to give the floor to the thesis supervisor. Alexander, please tell us about the candidate for the degree. Not about the work, but about the candidate. Okay. If I characterize the candidate of the thesis and the thesis itself, the style of work, I can say the following thing. We worked for a very long period of time together. During the first 2 years, I was given lectures on mathematical analysis, and Mikhail actively participated. He asked questions, and he showed that he has a good understanding of the topic. Then I was his academic supervisor during the specialization course. I was his academic supervisor. Then he studied at the master's course, and he joined a PhD course simultaneously. But unfortunately, we did not defend the thesis at once, but it took certain time. But I should mention that he finally resolved this problem. He finally prepared the thesis, and he brought it for the defense, for discussion. And if we talk about the style of work, we can compare it with the main goal that he resolves in the thesis. Mikhail considers non-stationary system and believes that in this system we have certain disturbances with zero average. This can be either fluctuations with high amplitude that strongly influence the system, and still we get conditions that guarantee that the system remains asymptotically stable. And if we talk about the regime of work, those were these fluctuations of this type, different disturbances that were quite strong, but in accordance with the results. The average system really was not zero, and indeed the result was asymptotically stable. So to say, this mode of work complies with the goal that is met in the thesis. And once again, I would like to mention that Mikhail demonstrated that he is a very good expert, and he published his results fully. He delivered presentations at conferences. He he also had grants from the Russian Foundation for Basic Research. He got grants from the university. He got his results, and I believe the results are quite decent. Okay, that's it. Thank you, Alexander. Now let's shift to the next article in our agenda. As we are holding our session with participants who are working remotely, I need to ask if there are any questions on the organization issues connected with this work in a remote mode. None? No. Okay. Dear colleagues, anyone else willing to speak out? Any questions? So, the last call on that. Okay. Okay, the members of the board have also given their opinion. Right now we have an opportunity to organize a short discussion of results. that will not be broadcast. How do you think, do we need such a discussion? No need for that. Okay. Dear colleagues, if they're working remotely, what do you think? No need for that as well. Okay. If there is no such need, let us continue our session. And so we all see and hear each other, no problems about that, okay. I therefore announce the vote on the award of the academic degree of the candidate of sciences in physics and mathematics to Mr. Voloshin, and specialization 051301, system analysis, management and information processing, physics and mathematics. And let me remind you that the decision of the dissertation board on conferring the academic degree is positive, provided more than 50% of the board members, but not fewer than 3 people, voted in favor. That's in conformity with section 23 of the order. So, Alexander Kamachkin, what's your opinion? Turn on the microphone, please. Yes, I vote for. I believe we should award the academic degree to Mr. Voloshin. Okay. Professor Provotorov, what's your opinion? Yes, I fully agree with that as well. I believe that we should award the academic degree of the candidate of sciences to Mr. Voloshin. Okay. Valentin Tai, what's your opinion? I also vote for. I believe that Mikhail has presented a very good finished work, and he's really a good researcher. Okay, thank you. Then Denis Yefimov. Professor Yefimov, what about you? Yes, I fully support the award of the academic degree to Mr. Voloshin. I believe he deserves this degree, sure enough. Okay. And I, chairman of the board, Alexander Peterhof, I also vote for the award of the academic degree because I believe that the work really complies with all the necessary requirements, and Mr. Voloshin has shown that he's a very good researcher, and he deserves the degree of the academic degree of the candidate of sciences in physics and mathematics. So, distinguished colleagues, out of the 5 members of the board who participated in the vote, 5 people voted for the award of the academic degree, no one voted against, and no one abstained from the vote. Therefore, we award the academic degree of the candidate of sciences in physics and mathematics to Mr. Voloshin in specialization 051301, system analysis, management and information processing, physics and mathematics. So, distinguished colleagues, as our session was held remotely, I would like to ask the members of the board or candidate for the or Mr. Voloshin, I would like to ask you if you have any questions on the procedure. No comments, no remarks on that. No remarks. Okay. No comments about that. Okay. So I give the floor to Mr. Voloshin for his finalizing remarks. Thank you so much. I would like to thank my thesis supervisor for his support, for his guidance, for the interesting problems that we considered, for the questions that we managed to get answers to. And I would like to thank everyone present, the members of the board, for valuable comments, for the questions that you've asked. And I would like to thank the technical service who made this defense possible. Thank you. Thank you. Now comes the most pleasant part. I congratulate you with the award of the academic degree of candidate of sciences in physics and mathematics, and so congratulations. Thank you, everyone. We stop the broadcast and we finish our session. So, goodbye.